My name is Michal Srb, and I'm a software engineer at Convex. And my goal today is for you to understand what Convex is, how it relates to React, and whether it is something that you should give a try in building your own full stack app. Before I joined Convex, I spent over 7 years building new products from scratch at Facebook. All of the products I worked on used React or React Native. They were all full stack apps. They all had user interfaces where people would come and perform actions and make changes visible to other users of the product. And I loved building products like this, from figuring out the user experience to architecting how the backend dealt with data. But I was very privileged in that by the time I joined servers or scaling the database, but this made me really worried about leaving the company. I didn't really want to go and learn how to be an SRE and work with AWS console or learn Kubernetes. Not because those are not cool technologies, but because I love to work on products and I don't want to, quote unquote, waste time re-implementing the wheels that every full stack app needs to get going. And this is why I joined Convex, because the vision for Convex is that most developers, software engineers, startups shouldn't need to be or have infrastructure experts to build products for people. But that's enough talking about myself. And this is only really a part of what Convex is all about. And so to get you to understand Convex, I'm going to start from the very basics, which has been spoiled by me showing you this app. So let's see what I'm sharing here. On the left, I have a web app. It's your super simple counter. I can click on the button and the counter increments. It's perhaps the simplest, interesting React app. And if you're familiar with React, the code on the right here is very straightforward, right? So I am using a useState hook. I pass it the initial state of the counter, which is 0. And I get back 2 items. The first one is the value, the current value of the counter, which I use to render my UI. And the second item that I get from useState is the set function. And in the callback of the button, I can pass in a new value for the counter, and the counter updates. So that's how it works. And this trivial component shows a fundamental aspect of React. When I tell React to update the count value here, I don't have to tell it as well, oh, by the way, update this component, right? React figures that out for me. It knows that it needs to re-render this app component if the state changed. And after all, it is in the name, React. Reactivity is baked in. And while there are different approaches to reactivity, and this is perhaps a very crude one, it is a really nice programming model, right? I declaratively describe how the state should translate to what the user sees on the screen. And then I sort of imperatively inside of the callback say, this is how the state should change. And the two together are tied in by React. Well, this is all nice for the client-side application. But what if I want the state here to be persisted? What if I want to reload the page and see the same value? You can see here that when I reload the page, the value is lost. Most real applications that help people connect or buy goods or use services, can't make do with an ephemeral storage of state. They need to write into something like a database. So let's look at a current popular approach to building a full stack app that uses a database. As an example, I used the T3 stack, which uses TRPC and Drizzle. I'm going to switch to it as well. This is the UI. And this is a classic single page app, but it now talks to a Next.js server, which talks to a database. And this could have been Firebase or Superbase or Mongo or even Django or Rails. It doesn't really matter. The point I'm going to make is not specific to any particular traditional database or backend. So let's look at the code first. This uses gRPC. I basically define two endpoints. The first one is counter get, and it's a read endpoint. I give it an argument, which is the name of the counter, and I get back the counter value. And the second endpoint is called counter increment, and I can use it. I can basically call it from my button on-click handler to mutate the value in the remote database. And now, if I look at this code that I actually have running here, and I click the button, you can see that the counter is not changing. This is the world's simplest, most broken counter. And the reason is that in this code, right, I'm not using React state. I'm using a remote database. And I haven't told React, hey, you need to re-render this component, or re-render the whole page, or rerun this query. And because I haven't done that here, the counter is not working. The app is not working. And I'm kind of like, this is very obvious if you're familiar with React and with traditional databases, but I'm harkening on this point because I think for React developers, this is really the most interesting part about Convex. And that is that it does this differently and it gets it right, in my opinion. So let's look at the Convex version of this app. So again, very similar. This is using Convex syntax. I also have essentially two endpoints, which I call the same. So I'm using a useQuery hook from Convex, and I pass it a reference to my endpoint and the arguments to the endpoint. And let's just look at how the implementation of this endpoint looks. So this is a query, which in Convex really is two things. One, it's a public endpoint. You can call it from via HTTP or from various clients, including React via the useQuery hook. Here I declare the shape of my arguments, which are actually validated by Convex at runtime. And this particular query, the second thing that it is, it has access to the database. It's actually a function that's running inside of the Convex database. So this particular one reads from the counters table. It uses an index. It gets a particular counter, and then it returns its value if it's there, or returns a default 0. So now looking back at the client-side code here, there's a use mutation hook, which is, again, very similar to gRPC. And again, I pass it a reference to the endpoint. And now I can call my mutation endpoint from the on-click handler. And let's see what happens. When I click the button, the counter updates. Yay, it's a working counter. But the amazing thing, right, why I'm talking about this is that I didn't say anywhere in this code that this component needs to be re-rendered when the button is clicked. I just made a write, and Convex automatically figured out that this read needs to be updated. And this is how the first version of this counter app, with which used useState, worked. And so I think this is really the interesting point of Convex, the thing that when people figure it out and when this point clicks for them, they're like, wow, this really simplifies a lot. Because while I've been showing you the simplest possible example, the quick start component, this problem of which component should re-render and when is a problem that becomes bread and butter of the React, of React developers. As the app grows in complexity, right now it's really easy. We could just render the whole component or re-render the whole page. But doing that all the time is not really feasible. If we could just re-render the whole page all the time, we wouldn't need React. But even if we did do that and just reloaded the page every time, that approach would not work when the change is not made by the current client, but when the change is made by another user or by the same user, but from another window or device. And the beauty of Convex is that, like React, it figures out what needs to change for us. So now you might be thinking, this is some kind of a hack. Maybe the client knows that we made a write, so it just refreshes all the reads, or every read is subscription. And when anything in the database changes, all the queries update and all the components will render. Something simple. Well, that is not the case, and I have demos to prove it. So here I have a split view, and I'm running the same app. It's still the same, this exact same Convex app. On two different ports. So there's no local storage or cookies shared between these two tabs. And you can see that when I increment the counter on, in one of the tabs, the counter automatically updates in real time in the other tab. For the second point, I have a slightly more complicated demo. So in this case, this is also a Convex app, but I just took that component that was a counter and I made 3 of them. And you can see that I have 3 counters. I call them first, second, and third. Otherwise, the code is exactly the same and the backend is exactly the same. In fact, I'm using the same backend. And now you can see that when I press the counters, they update as you would expect. But what I can do, right? The question is, okay, is the whole page being rendered because one of the counters changed? So to answer this, I can enable this option, highlight updates when components render in the React developer tools. And if it works for me, which I hope it will, then if you can see it on the video, there's like a faint blue rectangle around the component that re-renders. If you've played with React developer tools, you're familiar with this. So what this actually shows is that when I press this button, only the component, only the one particular read that needs updating propagates back to the client, right? So I have counters, I have a table of counters, I'm mutating one of those counters, and only that particular subscription gets updated here. Yeah, so this is kind of a very simple scenario, but imagine that my query is complex and combines state from different tables in the database. The Convex database keeps track precisely of which queries depend on which parts of the data in the database. And when a write, a mutation, causes a query to get recomputed, all the clients that are currently subscribed to that query get an update. So this is the first aspect of Convex that blows people away. But there is way more. So let's talk about the sexy concept of transactions. And I'll start again with a familiar mechanism in React. Let's go back to our super simple React-only example and do something a little bit silly. So let me open the first example. I'm going to do something a little bit silly. Let's try to increment the counter by 2 in the most naive way possible. So I just call set count again. And if I try this, you can see that this does not work and the counter increments by 1. And if we look at the code, it's kind of obvious. This cannot work. The second call to set count doesn't do anything because this is the original count value. So this is basically just a no-op. This code just looks wrong. But this is a contrived example. In real complicated components, this could happen without us noticing. In fact, this is such a common problem in React that React has a solution for it. Instead of passing a value directly to the set function, we can give it a function which takes the previous value of the state and computes the next value of the state. So we can do that here, right? So now this inner function takes the previous value of count and returns the update. And now when I try the app, it in fact increments by 2. So this is where transactions come into play. What we really want is to read the old value of the counter and then update it, making sure that we're not reading a stale value, or that one update isn't getting overwritten by another one. And React ensures that this is the case when we pass a function to the set function, because it applies all the updates in a sequence. In database lingo, this is similar to serializability. It means that the outcome of multiple operations is equivalent to the one that could have been obtained by running them serially, one after another. And React literally serializes the state updates, at least for one particular piece of state. And so you can imagine that we might have a similar problem with a mutation in a database. But the problem with databases is we don't want to run every mutation one after another. This would be a huge bottleneck of our system. If our mutations took 10 milliseconds on average, our whole database could only handle 100 mutation requests per second and no reads at the same time. So let's see the issue in practice. Let's go to the TRPC version of the app, and let's look at how the increment mutation is implemented. And again, this would be true for pretty much any traditional database. So can you spot the issue with the code here, given what I've just talked about? Let me describe what the code does, right? So first, we find the counter, which name is the name that we passed in as an argument to this mutation. So this is a counter. It has an ID and name and a value. If there isn't one, then we insert a new one into the database. And if there is one, then we update it. So we use the existing counter value and we add 1 to it, and we write it back into the database into the same counter, right? So the issue here is that another concurrent call to this mutation could completely break this logic, right? So imagine we have 2 calls to this mutation. The first one is running, and it reads the counter value. And the second one is running sort of concurrently. It also reads the same counter value, right? And then the first one adds 1, commits. The second one adds 1, commits, right? The same issue that we had with the super naive React code. We just lost the counter increment. And this is kind of the simplest example, but this problem can arise in much more complicated code involving state from many database tables and spanning many lines of code and different functions. And what's worse, you won't notice this problem when testing your code, right? If I just keep running, if I fix the counter here and keep clicking it, I'm not gonna see the issue. In fact, you might not even notice it after you deploy your code to production until your app has enough users to trigger this concurrent behavior of the mutation. And depending on the nature of the app, this is a bug that could have serious consequences for the people using your app, as it can totally violate the invariance you thought your code has, right? In this case, our invariant, we thought that what this code does is that it always increments the counter by 1. And so how do we fix it? Well, with Drizzle and with most traditional databases, what we need to do is we need to put the reads and writes together into a transaction. So let me do that in the code here. So I can call transaction, and I can wrap this code. But I'm not actually done. I need to take a handle on the DB and replace the existing ones here with the one that I get from the transaction method. And now I'm done. So the problem with this as a fix is that it is verbose, right? It's more verbose than the code that we had before. It is error prone. I could have, for example, forgotten the call to DB. And it is just easy to forget to do this. You might not think that your code might run into an issue that requires transactions, and then it turns out that it does. So Convex takes a radically simpler approach. Mutations always run as transactions. So switching to the Convex version of the increment mutation, you can see that the code is very similar, pretty much the same. But it doesn't have the issue that the original Drizzle code had, because this whole mutation always runs as a transaction. And there is a reason why traditional databases don't do this by default. And if someone asks in the chat, or if we have time at the end, I will talk about why Convex can do transactions by default. So I want to round up the discussion of fundamentals with one more property of Convex that helps build better experiences for people. And to demonstrate this, we'll finally upgrade to a more interesting and representative demo. So I'm actually going to maximize my window here. This is an eShop-like page. So I can add items to my cart. I can remove items from my cart. And this is a purely a React app. So when I reload the page, the state is gone. But what's important about this code is that everything that I do happens synchronously, right? So if I add an item from the inventory to my cart, the availability updates. And there's no intermediate state where I have added an item to the cart, I have it in the cart, but the availability of the items has not yet changed. And this is because I'm using React State. In fact, I have all of the state for this whole app in one component. But what happens when I try to move the state to a database on the server, right? First of all, there are two different pieces of state here. The items in the inventory, they're global. So I want all my users to see the same inventory. And then the cart is specific to each individual user. When we move the implementation to use a remote database, we want to retain the existing behavior that I talked about. We want, as the inventory updates, the cart to update in lockstep. What we don't want is to have one part of the UI update while another is stale or showing a different state. And if in the last 10 years you've used the phone with an app and the app had notifications and you had the notifications badge on, you know what I'm talking about in terms of how frustrating it is when this is not correct, right? So you have a notifications badge on your app in your phone, and then you open the app and there are no notifications, right? So this is an example of inconsistency in the UI. And this kind of issue happens all over the place, all over mobile and web apps. You can notice it everywhere. Sometimes the state updates quickly. Sometimes it just stays inconsistent and you have to reload the page or kill the app and restart the app to get the state to sync up. And this is usually caused by two different parts of the UI or different screens or pages fetching the particular piece of state individually, right? So maybe the badge hasn't updated, but the information inside of the app has. And less often, this is sometimes caused by the application server being what's called eventually consistent, where as the database, as the backend processes the changes, the users are actually able to observe the changes sort of in between, right? Which is not possible if the changes are made in a transaction. So this is where the first two aspects of Convex I talked about, that is the reactive model and transactions by default, come together. With Convex, no matter how you split up the queries that power a page or app, you always see a consistent view of the data in the database. And to prove this, we can have a look at the Convex version of this app, which I have here. So now when I add the items from the inventory, my cart updates. When I update my cart, the inventory updates. And it's happening in lockstep as if the state was held by React. But if I reload the page, right, the state is persisted. And there are two components here. They're each subscribed to their own query, right? Because the inventory might update more or less probably more frequently because all users are updating it, and my own cart might update less frequently. So I've separated the two states. But Convex ensures that when the page is rendered, all of my queries are mutually consistent. And we can see now when I switch to a split view that this is true even across different users, right? So for each individual user, the view is always consistent. And you can see that as I play with the inventory for one of the users, that it updates for the other user. So I'm just gonna check the chat. Awesome. So I mentioned at the start of this workshop that at Convex, we believe that most apps, most startups do not need bespoke infrastructure. And so far, I have talked about some of the fundamentals of how Convex works at runtime, but now I really want to focus on the developer experience, the experience for us, developers building products and systems. There are key attributes that I personally want from a platform to consider it having a great developer experience. So number one, the platform should be fast, right? I want to make changes and be able to test them instantly. Without this, simple tasks can take hours as time is burned, sitting and waiting for code deployment or repeated manual steps, like those 1 minute delays. If you're running into them again and again, they really add up. Two, the platform should be predictable. I want to be able to understand how my code will behave in production. We have already touched upon this with transactions. Unpredictable code leads to the worst kinds of bugs that take forever to debug. And I personally prefer spending my time on improving the quality of the product I'm working on over hunting bugs. And number three, the platform should guide me. Anytime a machine can lessen the load, point out issues, do things for me, I can take that time and spend it on the things that machines still seem to be unable to do on their own. So let's switch gears here and look at Convex from the perspective of a developer. I'm going to use the Convex Hackathon template, which is this one. You can access it at convex.dev/hackathon. It's linked from here. You can also find it on our GitHub. And I basically followed the README here, and I've already cloned the code, and I ran npm install. So let me open. I have it open here. So yeah, this is the code, and I've opened the terminal, and now I'm going to run npm run dev. And we can check what's here in package.json. So this actually does two things. It initializes the project, and then it is going to run our front end and back end CLIs. So first, we're going to initialize a project. I don't have a project for it. By the way, if you're going to do this on your own, you would have to log in to Convex, which is entirely free. But I'm already logged in on my Mac. So I'm going to configure a new project in my team, which you're only going to have one team, and I'm going to leave the name as is. And now I'm getting two tabs open. So the first tab is the app that's running, and the second tab is the Convex dashboard. And I'm going to bring these, and I'm going to have them open next to each other. Cool. So let's just play around and see what we're getting here. So this app is an idea generation and sort of a note-taking app. So I can say, what's my idea here? My idea here is to give a React Miami workshop, and I can save the idea. And as I save the idea in the UI, you can see that the Convex dashboard updates, right? And just like the app itself is reactive, the Convex dashboard is reactive. So what I can do here, I can, for example, change the text and on the dashboard and the text updates. Or I could add more ideas from here. So an idea from the dashboard. And when I hit save, I can see the idea on the dashboard. So this is a Convex dashboard running against my Convex backend, which sits in the cloud. And I have my React app powered by Vite running on localhost connected to that backend. What else do I want to show you here? So besides kind of playing around with the documents in my database, we also have this handy function runner. So this app has endpoints, like I showed you in the examples before, and they're listed here. So there's list ideas. This is the one that's powering the list here. It's a query. And then I have the save idea mutation that's being run from the button. So I can also, from a function runner, run the mutation from the dashboard and see it update in the app and reflected in the table. Everything super quick, super reactive. And we've recently added the ability to write queries directly in the dashboard. So I can, this default one takes the first 10 ideas from this table, and I could say, okay, only give me 2, and then you can see the update here. So this is very handy if you want to, experiment with the query syntax, just kind of learn. Okay, a couple more things on the dashboard since we're already here. There's a functions tab, and this one has all my code. So this is mainly handy to make sure that the code that's running in the cloud is the code that I think is running in the cloud. But it also has invocations, errors, and execution time graphs, so I can kind of see how my functions are being exercised. And the last tab in here that I wanted to show off is the logs tab. So this is super handy when you're working on a Convex app and you're debugging things. You can see all your logs in here on the dashboard. So if I create another idea, we can see that the save idea mutation ran, and then the list ideas query was recomputed and updated, right? Because the list has changed. So I think that's enough for the dashboard, and let's go make some changes. So remember that I ran npm run dev, which I'm showing off here. So now we're running both Vite, which is going to take care of updating the front end, and the Convex CLI, which is going to take care of updating the backend. So let's make some change here. Let's change this title to React Miami app. And when I save the file, the title updated, which is great because it means that Vite and React Hot Reload are working for me. So all of the Convex code lives in a directory called Convex, which it's a very inventive name. And in this case, I have these endpoints declared in the my functions file. So let's see if we can change how these endpoints works. So for example, list ideas, this is the simplest query. It just queries the ideas table and returns all the documents in that table. So let me change this. The default ordering in Convex is by creation from the oldest to the newest. So that's ascending order. And now I'm going to change it to be in a descending order. So from the newest to the oldest ideas, we should see. And you could see that as I saved in the file, the Convex CLI ran. It bundled my backend code. It pushed it to Convex. And then my app automatically updated, right? Which took 1.6 seconds right now. So that goes to the first point that I mentioned, right? Things need to be fast. But this was a very simple change, so let's do something more complex. The UI has this checkbox, include random ideas here. And when I play with it, I can see actually that let's get a random idea in here, and I'm just going to do it because I want to save that random button for later. I'm just going to do it from here. So now the another idea is a random idea, but I can see that when I click on the checkbox, it doesn't do anything. So let's fix that. So what we need to do is, let's see. We have the list ideas query here. Let's see how the checkbox is implemented. So include random ideas. Here it is. So the checkbox, when it's changed, it sets local state, this include random. So that's great. So I already have the include random, the state of the checkbox in my components React state, but it's not being used. So let's try to pass it to my query. And when I try to do that, you can see that I immediately get a TypeScript error, which says, basically, this query does not accept arguments. So that's great, right? Because this goes to my third point, where the system is guiding me, right? And I didn't have to save this file and figure out that the app is going to be broken because I'm passing an argument that the query does not take. TypeScript and end-to-end type safety provided by Convex lets me know that, yes, indeed, this is wrong. So let's go to the query and support that additional argument. So we're going to call it include random. And Copilot is helping me here. Thank you very much. And you can see that I haven't even saved this file, and the TypeScript error is gone, right? And this is because TypeScript is running in the background, and it's actually taking my code without, not the saved code, but the code that I actually have in my editor, and it's checking against that. And because there's no cogen involved in changing the type of the arguments for this query, I get an instant update. But I actually want to do one more thing. If I saved this file and this query and I pushed it, this actually says whenever you call this list ideas query, you have to provide the include random argument. And our app, although because I also haven't saved it yet here, it's still, the live one is still not providing that argument. So I want to show a little trick. I can make the query backwards compatible by saying this argument, the include random argument, is optional. So now when I save the backend file, Convex updates, the app still works. Nothing's changed here. And now I can save the front end file. And although the checkbox is not working, the app still works. So that's great. So we are propagating the state to the backend, but we have not used it. So let's use it. The really nice thing about Convex is that these functions are just JavaScript or TypeScript. And so things that you would have to kind of figure out the SQL syntax for, you can just use JavaScript for. So let's do something like this. All variable is going to store all the ideas, and then I'm going to say return if the include random argument is, and now I have to get the logic right. If it is false, right? This is the special case where include random is false, then I don't want the ideas that are random. Otherwise, I do want all ideas. Okay, so now we're going to see if we've done this correctly. So I save this file. Convex pushes it. I did not implement this correctly. So let's see. No, I did implement this correctly. Cool. Yes, so you can see that now when I toggle the checkbox, if I untoggle it, I don't get the random idea. If I toggle it, I do get the random idea. So that's all good. What happened there was that the page reloaded at the same time. And as you can see, because I don't have a loading state here, it takes a second to load the data from the backend. Something that we could handle with a little bit of UI nicety to provide some sort of load indicator. Cool. One more thing I want to mention. I think I mentioned this before, but these arguments here, they do two things. One is the args parameter to the implementation of the query is typed now. So if you're familiar with Zod, this syntax will look very similar. You're just very familiar. You just replace Z with V, and this is the Convex syntax for argument validation. But besides the TypeScript type, this actually does enforce that only this argument with this type is allowed for this query. If a caller passes in a different argument or a type or a different type, Convex will not run the query at all, and it will just throw. And this is super important for security because if you just let anyone call, your endpoints are public, right? You don't control all the clients. So you could have a malicious user or a hacker call your mutations with arguments that your code is not expecting. And you might store things in the database that you didn't want to, and so on. So argument validation is really important. Cool. So this was still pretty straightforward. Let's do something even kind of more complex. So what about, I showed you that we have the arguments typed, but what about the result of the query? So I can hover over ideas here on the front end, and you can see that TypeScript is telling me that they're either undefined, which is the case for when the query is loading, or they are an array of any's. And an array of any's is not very helpful, right? That's not a very specific type. It's just an array of some things. So let's get a more specific type. And we can do this by declaring the schema for the tables in our database. So this is a very sort of a different thing about Convex. Convex is not really just a document database or just a relational database. It is kind of both. It's a mixture of both. And so right now, I have no schema. Right, even in the Drizzle example, I had to declare a schema. If you're using Superbase or some other SQL database, you would have to declare a schema beforehand. But here, there's no schema. I just have this backend code. I have the mutation. It says, write idea and random fields into the IDs table. I never had to specify what that table looks like. But now I want to, because I want to get additional types. And here's a cool trick of doing it. So in the Convex dashboard, there's this handy generate schema button. And what this UI shows is what the schema should be based on the things that I currently have in my database, right? I already have data with some fields based on my code. So I can just copy this code and paste it in here, and then save it as schema.ts in my Convex folder in my project. Right? And you can see that the schema validation has completed. So what's actually happened is that we've uploaded the schema to the Convex backend, and Convex verified that all our documents in our database indeed match the schema. So you can actually see now, we can switch to the saved tab here, and you can see this is the schema that's saved. And the main thing that we wanted out of this is that now when I hover over ideas, I get the full type, right? So this is the type that I get from the database. These are the documents, and the additional _ID _creation time. Those are fields that Convex creates by default for every document. So awesome. Now we have end-to-end type safety, not just for arguments, but also for the output of our functions. So now that we have a schema, let's add an index. Indexes are actually simple, but a very powerful feature of databases. Without them, looking up documents with specific values would always entail scanning the whole table. So with large tables, this would be prohibitively slow and expensive. So you can think of an index as a binary search tree, basically, with leaves being the documents in the table. And the point is that it allows logarithmic lookup. So let's say you have a table and the table has 10 million documents, 10 million rows in it. It takes 10 steps instead of 10 million steps to find a single index document, right? Which is some sort of a property. Let's say we could be searching the ideas by their text, right? And in this example, we probably don't need an index because our users are probably not going to insert, tens of thousands of ideas. But let's just use this as a learning experience. So first, I'm going to declare the index in my schema. And you can see that all the Convex APIs are typed with TypeScript. So, even if you can also use JavaScript, but you will still get IntelliSense. So let's call this by random, because I want to actually index on the random field so that I can power this checkbox with an index. And you can see that I'm getting the option of which fields I want to index. I want to index the random field. Great. It's also awesome that we're using JavaScript and TypeScript for all this syntax, so you don't have to learn another schema declaration syntax. And actually, as you can see in the terminal output, we've added this index. And what Convex did was it actually backfilled the index, right? So I was saying this is sort of a binary search tree, and we already have some data in the database. So as soon as we added the index, Convex populated it, backfilled it. And now, whenever we write a document into this table, the index will be updated transactionally at the same time as we're making the change. Cool. So that's all great. And in traditional databases, an index whether an index is used would depend on a query optimizer or query planner. And this goes to my second point about predictability and control. In Convex, you are in control of whether to use an index or not. It's up to us as developers to decide, how much we want to optimize and whether we want to use an index. And I don't have to worry about, an unexpected behavior occurring in production where the query optimizer decides that it can't use the index or it shouldn't use the index for whatever reason. I understand my data and I understand kind of the implications of when the boost from the index is worth it. So let me just quickly implement this query just as an example of syntax. So this time I'm gonna just use a typical if clause. So if include random is false, then I'm going to use the index. So I'm going to query the ideas table. That is true. And then I'm going to use with index. This is the only index I have. And here, I could use indexes for range queries. So I could say that I want, if I had people in my database, I could say that I want people in a specific age range. Here, I just want to say that if I don't want to include the random ideas, then I want random to be false. And I will use the order and I will collect all the results. Otherwise, I'm just going to return all the results. Live coding. Cool. So pretty straightforward. Now I save, my code updates, and I can test that indeed we've implemented this correctly. But now it's powered by an index. So it's actually, if we had tens of thousands of ideas here, it would be way more efficient, the query, which skips all the random ideas. So let's get to this big generate a random app idea button that I've been ignoring this whole time. I'm going to click it. Let's see what happens. So what happened was that we got a new idea, and I did not have to type out what it is, which is great. And as it turns out, this text is not actually generated by logic that's in my Convex functions. It's actually generated by sort of a third-party service, if you will, by an endpoint that we're using here from appideagenerator.com. Because up until this point, I've only talked about Convex as a hosted database in the cloud. And all the functions that I've showed you, they can read and write to the database. But Convex is not just a database. It is a fully featured application backend. And the first thing that a backend might need to do beyond talking to its own database is to call other services for processing payments, talking to devices in the real world, or talking to an AI. And because queries are automatically cached by Convex and mutations run as transactions that might be retried if they conflict, queries and mutations cannot call other services. And so for this, there is a third type of a function in Convex called an action. An action can be called as an endpoint by a client, or it can be scheduled from a mutation. And an action itself can call queries and mutations to access the database. So let me just showed you how this button is implemented. So let's go back to the client side, generate random idea. So you can see that I call generate idea. And this is a very similar syntax to the use mutation, but here we have use action. And we give it an endpoint reference, which in this case is an action. So what this action does is that it fetches from this endpoint, third-party endpoint, and it gets the response text, and then it calls the save idea mutation, which we've used for the save idea button, to save this, automatically generated idea. And this is a very, simple way of using an action, but it does have a drawback. If the action takes a while to execute, which can be the case with all sorts of kind of background processing jobs, task, AI workloads, there is no indication right now in the UI. It's pretty quick, right? So when I click, it's when I click. But imagine it took 5 seconds to generate the idea. There would actually be no indication in the UI that anything is happening. But often we actually want the in-progress state to be persistent and to show something to the user who's interacting with the app, but also to other users who might be interacting with the app. So I'll have a slightly different implementation here, which I will switch to. Maybe. Hoping I could switch to. Might have to type it out. Let me see. Let me just give me a second, and I will fix this. Cool. So let's go back to the client. So what I've done here is instead of using an action, I call a mutation. So this is, again, very similar as here. I have a new mutation called add random idea. And this mutation does 2 things. First, it writes into the ideas table. And it puts in sort of a placeholder. And we're going to use this to show to the user what's happening. And the result of the insert call is the document ID, the ID of the newly inserted document. And this ID I pass to the action that's going to actually fetch the text. And to do this, I am using what's called the scheduler. So this is another functionality that I have not talked at all yet about in Convex. But not only you can sort of call functions directly, from a client or from one another, but you can also schedule them. So the run after call allows us to schedule functions with a given delay from now. There's also run at, which allows us to run a function at a specific at a specified point in time, at a specified timestamp. And so what I'm doing here is kind of similar to a set timeout with a delay 0. I'm saying, okay, this mutation, all it does is that it creates this placeholder document. And then also, please schedule for later this action that's going to do something to that document. And I really like this example because it reminds me of React, right? So in React, our render, our component function, our render method is pure, and it should have no side effects. And for those, we have use effect, right? Which is kind of sort of on the side, please do something to the world. And this is sort of a very similar pattern where the mutation, it has to be idempotent. It cannot make fetch calls, but it can schedule actions. And so then in the action here, not much has changed. I again fetch from the endpoint and I get the text. And now I run a new mutation that instead of saving a brand new idea, I update the existing idea. And let's see if this, you gotta see the generating there. I could make it even more obvious that it's gonna take some time. So a couple ways of doing this. I could await a promise that's gonna sort of sleep. So let's say 5 seconds. So another difference between actions and mutations is that actions can be long running. So in this case, I will make the action just sit around and wait for 5 seconds. So now I get the placeholder, right? That's the first mutation call. And now the action is executing, which I could actually see in the logs here. And then I get the result out. So this is sort of a special way of using the scheduler for scheduling actions. But again, this is a super helpful schedule functionality. You can create all sorts of workflows, sort of a temporal style capability. Cool. So that's about it for what I wanted to cover in the workshop. And then just some sort of extras that I wanted to show off. We have had this project called AI Town, which has become super popular. And what's great about it is that it's got these little AI agents running around, and they create lots of activity on the backend. So if I show you the messages table, you can see we actually have 3.1 million documents in this table. And I'm showing it because we put a lot of effort into the Convex dashboard, and people really love it. So this dashboard, it handles 3 million documents just fine. And I can do things like query, where the author is, P6 I saw there. I apply the filter, I immediately get the results. So, this is really important for kind of making sure that this system, it's not just for examples that have 5 or 10 documents. The Convex database can handle a whole lot more documents, millions of documents. Tens of millions of documents. I also want to show you that besides scheduling functions, which is what's happening here, and the dashboard is showing us scheduling, we also have cron jobs. So you can say, I want a function to run at a specific time of the day or with a specific delay periodically. Again, this is very helpful for cleanup jobs, offline jobs, and so on. And let me just quickly run through other features that I have not covered yet. So, I've talked very much from the perspective of React developers and React being the client from which you interact with Convex. But, if you have other app ideas that, where you don't use React, we have other clients. So we have the Python client, we have a Rust client, which is sort of a basis. It's actually a basis for our Python client, and we're planning to use it to build clients for other native platforms. And we're also working on other JS frameworks and clients for those. And additional functionality that I haven't touched on, we have file storage. So you don't have to hook up S3 and go through all of that. There's this super simple API for uploading files to Convex, reading them, reading all the files that you have stored in Convex. We have full text search. So it's very easy to implement text search and just add it to your app. We have vector search, which allows you to search by similarity on documents that include embeddings. So this is sort of the typical retrieval augmented generated workflow for AI apps. And yeah, that's about it. There's lots of helpful things here in the docs, and we also have a very vibrant Discord. So if you have any questions after you watch this, if you try things out, and you have more questions, you can reach us out. You can reach us there. And now I'm gonna go over the chat and see if there are any questions here that I can answer. I see that folks have commented on the out-of-the-box IntelliSense, which is really helpful. Yeah, someone has wrote that it's crazy to think about all the things that they don't have to think about anymore after using Convex, which we get a lot from folks who try out Convex. And then there was a question about how do we manage a bunch of transactions? Is there a limit transactions? Is there a limit of the transactions that can be processed? So I kind of mentioned, I didn't describe it, but Convex uses optimistic concurrency control. So first of all, the transactions in Convex, they have the proper serializability property. So there's in other databases, you might have sort of transactions, but you might say, okay, I'm okay with violating some aspects of serializability. So in Convex, you always get proper serializability of transactions. And the way the transactions work is that if two transactions conflict, right, one of them goes through and the other one is retried at a sort of a later timestamp. So it is rerun with the newer state of the database. And this way Convex can handle a lot more transactions, just a really large throughput. I probably didn't do this justice, but you can read definitely more in the docs. Actually, if you go to the database section, and I think in advance, you can read more about OCC and atomicity. And then there's a question about caching. So I didn't stress this enough, I think, in this talk, but all queries are automatically cached. So if you have another client that calls a query with the same arguments and none of the dependencies of the query changed in the database, the result is automatically cached. Caching is famously one of the hardest problems in computer science. And Convex basically has a perfect cache and a very efficient one at that, right? Because all the queries track their changes. So, the tracking actually happens on index ranges. So if I am looking up a document in my query by ID, only the write to that document affects the query cache, kind of busts it. Or if I'm looking at a range within my query, then if there's an insertion into that range, or if there's an update within that range, then the query gets updated. But outside of that range, the query is not affected. So this is really cool. And with correctly coded Convex apps, you can get awesome performance and sort of awesome, cost savings because your cache is perfect. And there's this longer question about building a social media schedule app where users can select their time zone, date range, and what time to post on social media. If I choose to run the scheduler for 3 days at the same time, 5 p.m., then for these days on 5 p.m., the post will be published. could anyone give me an overview of how we can build this? This is totally, definitely buildable with Convex. And if you're struggling with with anything, please do reach out on our Discord, kind of provide all the details that are necessary, and there we can really help you out. And it's important for us, right? Because we're getting feedback about what we still need to improve in our docs and in the platform. So it's a sort of a two-way street. We help our users, and our users help us improve the platform. Cool. So I think that's enough for today. Thank you, everyone who tuned in. And I think we'll post this recording later on. So hopefully more people will get to see it. And I am personally excited for React Miami, and hope to see you there or at another place, another time. Thanks so much, and have a great day.